Here is the next example. In this example, by using Mason's gain formula, find the transfer function of the signal flow diagram, graph or diagram. Actually, it's a diagram. Now, so first step one, always find forward paths. So forward paths, I have P1. Forward path is nothing but starting from input reaching the output. P1 is nothing but Z1 times Z3. Okay, and P2 I have from here Z1 Z2. Okay, now P3 part 3, I'm going to go over color. Let me see if I can get different color. Okay, from here Z4 minus H2 Z3, Z4 minus H2 Z3, and path 4 I'm using green, G4 minus H2 G2. Okay, minus G4 G2 H2. I should have written it properly, but yeah. Now step 2, find number of loops. Okay, loops is nothing but starting point and ending point must be same. Starting and ending point must be same. Okay, so here and without touching any path more than once. So here I can say that is loop 1, Z3 H1 H2. So minus H2 Z3 minus H2 H1. So that's loop 1. And loop 2 is Z2 H1 minus H2. Loop 2 is Z2 minus H1 H2. Okay, now 2 non-touching loops. So next step is find 2 non-touching loops, 3 non-touching loops. So here non-touching in the sense they shouldn't touch any path or they shouldn't touch any node, both. Any one of them satisfies, that's good. So here both loops have a common path. You can see H1 H2 is common in both loops. For sure they're using those 2 paths. So for sure there are none 2 non-touching loops. Okay, now we'll find delta equal to 1 minus L1 plus L2 plus product sum of 2 non-touching loops. So if you have say non-touching loops as LA and LB are non-touching loops, we don't have them here, I'm just giving you an example, and LC and LD are non-touching loops. So what we're going to do here, LA times LB plus LC times LD, that's what I meant. Okay, so first we need to multiply 2 non-touching loops and then sum all the individual 2 non-touching loops. So in this case we don't have this part, so I'm putting that as 0. Okay, so delta equal to 1 minus L1 plus L2, that's delta. Now transfer function is 1 over delta sum of P of k delta of k, where k is number of number of forward paths. So here k is 4, so I'm going to use 4. Now you need to find delta 1, delta 2, delta 3 and delta 4. We already know delta. Now P1, P2, P3, P4 we already know. Delta 1, delta 2, delta 3, delta 4 we don't know. We're going to find those. So delta 1, to find delta 1, it's a simple way. Take whole delta. Now eliminate any term which is touching path 1. So to find delta 1, okay, so here is path 1. This is what path 1 is, Z1 Z3. Okay, now take whole delta, which is 1 plus Z3 H1 H2 plus Z2 H1 H2. Now delta 1 equal to copy delta except any element which is touching that path 1. So if you look at Z3 H1 H2, Z3 H1 H2, so Z3 is already in path 1, so eliminate that. The next one is Z2 H1 H2. Z2 H1 H2. It's look like none of these elements in path 1, but at the same time they're all touching this node. So eliminate that. So delta 1 equal to 1. Now delta 2 equal to path 2. Path 2 I have which path? Path 2 I took this path Z1 Z2. Okay, so Z3 H1 H2. Z3 H1 H2, they are touching this node. Okay, the path 2 is touching this node. Z3 H1 H2 is also touching that node. So eliminate that. Z2 is already in there, so delta 2 equal to 1. If you do it in the similar way, delta 3 also must be 1. Delta 3, I have which path I'm choosing? Minus G3 G4 H2. So I'm coming this way, Z4 minus H2 Z3. Okay. So here I'm going to put 1 plus Z3 H1 H2. Z3 is already in there, path 3, eliminate that. And Z2 H1 H2 is in there, so eliminate that. Okay, either node is touching or path is touching, eliminate all those terms from delta to find delta 1, delta 2, delta 3 and delta 4. You will end up with the same thing. Okay, so the final answer must be, so once we find delta, here is the delta 1, delta 2, delta 3, delta 4, which are all 1. Our final transfer function is Z1 Z3 plus Z1 Z2 minus Z1 Z3 Z4 ZH2 minus Z4 Z2 H2 over 1 plus Z3 H1 H2 plus Z2 H1 H2. Thank you. I'll stop it here.